All right, kids, how we doing? How we doing? So, last week we talked about writing equations based on a graph. Okay, so now we're going to take that. We're going to talk about something else. We're going to talk about writing equations based on patterns. They're also called arithmetic sequences or arithmetic sequences. It's pronounced arithmetic. First, I want to do this little thing with you. So it says work with a partner, so obviously it's just going to be us. Describe the table. So one star, how many sides are there? So if we count them, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 sides on that. So here, if I have 2 stars, how many sides do we have all together? Well, of course, if there's 10 here and 10 here, then there's 20. 3 stars would have, write this in your notes, okay? Write it down. Pause the video if you have to. 4 stars would have 40, 5 stars would have 50. Now, come to our chart. So, number of stars n, so of course, this is our input. This is our output. Input goes down here, output goes here. So 1 star had 10 sides, 2 star had 20 sides, 3 star 30, 4, 5, 50. What do you notice about our graph? What do you notice? Okay, think about it. Have some ideas, jot them off to the side. What do you notice about this graph? And we'll come back to it, okay? Let's do it again. So again, how many circles are there? Well, 2. Zoom in if you have to, but there's 2 circles, right? How many circles are here? Well, count them. There's 3. Put this in your notes. So again, we want to graph this. Again, I've got input on the top, output on the bottom. So 1 is 2, 3, 2 is 3. And again, I want you to make some conclusions. Okay, what do you notice about the graph here? Is it the same as this graph? Did you notice the same thing? Okay. So let's do this one more time. So 1 is 2, 4, 6, 8, 10. All right. Graph them one more time. And again, what do you notice about the graphs? Off to the side in your notes, what do you notice about the graphs? Make a little guess as to what you think I'm going to say is significant about these graphs, okay? All right, so an arithmetic sequence. In an arithmetic sequence, write this down. Difference between each pair of consecutive terms is the same. The difference is called the common difference. That's going to come up again later. Each term is found by adding the common difference to the previous term. So here, if we have a list 5, 10, 15, 20, we add 5 every time. 5 is the common difference. Okay? Again, pause this if you need to, write this in your notes. Write the next 3 terms of the arithmetic sequence. So if you can't see these, I'll write them bigger because I know it's a little hard sometimes. First off, I need to find the common difference. How is this changing every time? So here, it's going down 7, down 7, down 7. Nobody said they had to be positive. Nobody said they had to be going up. It just had to be the same. So it wants me to write the next 3 terms, so I would continue to go down 7 3 more times. So that would give me negative 35, negative 42, negative 49. Okay? All right. Write the next three terms of each arithmetic sequence. So, again, I'll rewrite them. First, I need to find the arithmetic, or find the common difference. How much is it changing every time? And is it the same? Here to here is, of course, down 12. Sorry, up 12, up 12, up 12. So I found my common difference. Now just do it 3 more times. 36, 48, and 60. All right, let's do number 3. You better be good with fractions, better be good with decimals. Find the common difference. How much is it changing every time? Well, 4 to 3 3/4. If you can't do fractions very well, get out a calculator. 4 minus 3 3/4 equals. Well, this is going down 1/4. Here to here. Is it the same? 3 3/4, 3 1/2, down 1/4, down 1/4. So again, if you're good with fractions, you can knock this out pretty quick. If you're not, grab a calculator and get it worked out. Goes down 1/4 is 3, 2 3/4, 2 1/2. All right, so it's changing, going down 1/4 every time. All right, graph the arithmetic sequence. What do you notice? So this is what we've been talking about. What do you notice? Again, if you can't see these, those are the numbers, and it asks me to graph them. Well, I need 2 numbers to graph, so we're going to use the order that they're in. So this will be 1, 2, 3, 4. What are we going to count by? Let's count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. And these are going by 1s. You can count by whatever you want on your paper. Again, you should be writing this in your notes. So now, the first one is 4. The second one is 8. Third one is 12. The fourth one is 16. What do you notice? Think about some of those things you said in the beginning. Couple of things. If you have an arithmetic sequence, it will be a straight line. They will all be in a straight line. That's one important thing, how you can tell something's an arithmetic sequence. The other thing that's important is the slope of the line is equal to the common difference. So here I'm going, remember this was 4 to 8, so I'm going up 4, right 1. The slope is 4 over 1. So when we went back to some of these, now this is counting by 2s as this goes over, but so it's up 2, right 1, up 2, right 1. What was the common difference? 2. Here, this is going up 1, right 1, up 1, right 1. What was the common difference? 1. These were all changing by 1 every time. That's your denominator, because it's always y over x. So it's 1, 1. This here, again, the graph's not great, but it's going up 10 every time it goes over 1. This is going up 10, this is 1. So the slope is 10 over 1. The change in y over the change in x. So your common difference is your slope. So when I told you to write those observations and those thoughts, those are the 2 big things to take away from arithmetic sequences. Your common difference is your slope, and if it's an arithmetic sequence, they're in a straight line. All right, so does this graph represent an arithmetic sequence? If I give you the graph, is it arithmetic? Well, 2 things. Is it a straight line? Yep. Does it have a common difference? Is it all the same? Well, this one is 15 to 12, so it's going down 3, right 1, 12 to 9, 3, 1, 3, 1. Sure is. It's constant. It's a straight line. It has a constant rate of change. That's our slope. So, I didn't write an answer. So this one is yes. It has a constant rate of change. You could say that the common difference is the same for each point, or you could say they're in a straight line. So, graph the arithmetic sequence. What do you notice? So, we're not going to graph those. I want to take a look at this one down here. Does the graph shown represent an arithmetic sequence? Well, let's take a look at this one. All right, so my scale's counting by 2s. That's always important to note. So this is going up 2, right 1. So this first dot to dot is 2 over 1. What's the second one doing? Well, this one's going up 3. Look, I went from 4 to 7 here. It's going up 3, right 1. For the second time. Is that the same? No, obviously not. What's this one doing? It's going from 7 to 11. It's going up 4 when I go over 1. So does this one have a common difference? No, it's changing. It's different. It's not the same. You can tell by the lines, they change. They have a different slope. This one is 2 over 1. This one's 3 over 1. This one's 4 over 1. They're in difference. They don't line up. So, no common difference, not in a straight line. Okay? So, very important, we're looking at a graph to be able to tell if something is an arithmetic sequence. Doesn't have a common difference versus something that does have a common difference. All right, and that's it for today. We'll finish the rest of this up tomorrow. Good luck, ask questions.